Welcome to Design Principles. In this video, we are going to look at one of the most important guidelines in object-oriented design: favor composition over inheritance. By the end, you will understand why deep inheritance hierarchies become brittle, how composition avoids that trap, and exactly when each approach is the right tool to reach for. Inheritance feels natural at first. You have a base class, you extend it, and you get all that behavior for free. But as the system grows, problems appear. Every subclass is tightly coupled to its parent's internals. That is what the Gang of Four calls white box reuse, because you can see inside the parent. Change the parent and every child can break. Need a slightly different combination of behaviors? You end up adding more and more subclasses, and the hierarchy becomes a tree that nobody wants to touch. Think about Russian nesting dolls. Each doll is locked inside a specific larger one. The structure is rigid and predetermined. Now, think about Lego bricks. Any brick can connect to any other, and you can pull one out and replace it with a different piece at any moment. Composition works exactly like Lego. Instead of locking behavior into a fixed parent-child chain, you snap together small focused pieces of behavior and swap them freely. The principle says, instead of inheriting an implementation, define an interface that describes the behavior you need, create separate classes that implement it, and give your object a reference to one of those classes. That reference is called a delegate. The object does not know or care which concrete class it is holding. It just calls the interface. This is black box reuse. You depend only on the public contract, not the internal workings of any parent class. Let us walk through this step by step. First, we declare the log strategy interface with a single method, log. This is the contract, the only thing the client will ever see. Next, we create two concrete classes, console logger and file logger, each implementing that interface independently with no shared parent. Then comes order service, our client. It holds a private field called logger typed as log strategy. Just the interface, not any concrete class. The constructor accepts any log strategy and stores it. The setLogger method lets us replace that reference at any point, even after construction. Finally, placeOrder simply calls this .logger.log. It delegates the work entirely. At the bottom, we wire everything together. We create an order service with a console logger, place an order, then swap to a file logger, and place another. Order service never changed, yet its behavior is completely different. At runtime, when the client calls a method on the interface, execution jumps to whichever concrete class is currently assigned. That jump is called delegation. Because the client knows only the interface, you can add a new behavior by writing a new class that implements it, and nothing else changes. This is the open-closed principle in action. The honest trade-off is that you end up with more small classes, and you have to wire them together somewhere, usually in a factory or a dependency injection container, rather than letting the compiler handle it through inheritance. So when should you choose composition? Reach for it when behavior needs to change at runtime, when you have several independent dimensions of variation, like logging style and retry policy, that would explode into many subclasses if combined, or when a hierarchy is already growing deep and brittle. On the other hand, inheritance is still a legitimate tool. If you have a genuine is, a relationship that is unlikely to change, say, a square really is a shape in a small graphics library, inheritance is simpler and perfectly appropriate. The principle says, favor composition, not abolish inheritance. Let us recap. Inheritance is white box reuse. Your subclass is tightly coupled to a parent it can see inside, making the hierarchy fragile. Composition is black box reuse. Your class holds a reference type to an interface and delegates to it, staying completely decoupled from the implementation details. That decoupling is what enables runtime flexibility and clean extension. And remember, this is a guideline, not a law. When a relationship really is a stable relationship, inheritance is still the right choice.